All right, so moving on to section 10.2, angles of rotation. So still talking about trig functions. This page has a lot of empty space on it, so let's fill it up a little bit. Let's draw a triangle, kind of, oops, let's try it over here. Let's draw a right triangle, and since it's a right triangle, we got to make sure we have a right angle there. I'm going to put an angle up here. First thing I'd like you to do is, in reference to this angle theta up here, I'd like you to pause the video and label the three sides of this triangle with, well, what you think the appropriate labels are. If you can't think of what labels to give them, maybe think about the words adjacent, opposite, hypotenuse. Pause the video and label those three, please. Okay, you're back because you clearly paused and filled those out. So, in terms of adjacent, opposite, and hypotenuse, well, hypotenuse is the side that's always the longest side. It's always opposite of the right angle, so that's our hypotenuse. The opposite side is the leg. Remember, leg is one of the two sides touching the right angle. It's the leg that's not touching the angle that we're talking about. And then the adjacent side, in this case, would be over on the left side here. So remember, whatever leg is touching the angle is the adjacent side. Whatever leg is not touching the angle is the opposite side. So with that, thinking about the trig functions we talked about last week, we had three big trig functions that we've used: sine, cosine, and tangent. These are ones that are probably more familiar to you. Hopefully you remember them from geometry. And then I'm going to leave a little space because we're going to have to figure out what those are in a second. But on the right side, I'm going to put cosecant of theta, secant of theta, and tangent of theta. I want you to pause the video and I want you to think about those three words: opposite, adjacent, hypotenuse. Oh my goodness, I made a typo here, sorry. Cotangent, not tangent again. COT. I want you to think about how these six trig functions are related to opposite, adjacent, hypotenuse. See if you can come up with a way to finish the equation for all six of these. And maybe for the cosecant and secant and cotangent, maybe think about how you can relate them to the sine, the cosine, and tangent. Okay, you clearly paused. Let's keep going. So sine is the opposite side divided by the adjacent, goodness gracious, divided by the hypotenuse. Cosine, adjacent divided by the hypotenuse. Tangent, opposite over adjacent. You might remember, we talked about this last week, and you might remember this from previous classes. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So those three hopefully are already pretty familiar to you. The three newer ones, cosecant, secant, and cotangent. I'm going to first finish these equations off by relating them to what's like the sine, cosine, and tangent. And you'll notice I always kind of line them up like this. So sine and cosine are kind of left to right. Sine and cosecant are left to right next to each other. Same with cosine and secant, tangent and cotangent, because they are very closely related. For example, cosecant is 1 over the sine of theta. Secant is 1 over the cosine of theta. Cotangent is 1 over the tangent of theta. Now also tying that back in with opposite, adjacent, hypotenuse. Since cosecant is 1 over sine, it's the reciprocal of sine. We're going to take whatever sine was, opposite over hypotenuse, and take the reciprocal of that, hypotenuse over opposite. Cosine was adjacent over hypotenuse, and so the secant, which is the reciprocal, is going to be the hypotenuse over the adjacent. Cotangent is the reciprocal of tangent. So the tangent was opposite over adjacent. The reciprocal of that is adjacent over opposite. So just a very brief summary of some stuff that we looked at last week. And we're going to use some more of that again this week. Oh no, sorry, I'm getting ahead of myself. We're not using that this much this week, but we're going to be using that throughout this unit. Our goals for the week. I should probably change that to GFTW now that we're doing these just once a week. Whatever. We're going to start off by drawing angles. We're going to draw angles of various sizes. Then we're going to talk about these things called coterminal angles, and then follow that up with reference angles. And then talk about the 6 trig functions for points in the coordinate plane. Let's start off with the beginning. How to draw angles. We're going to talk about these things called the initial side and the terminal side. The initial side of an angle is going to be the starting side. The initial side is where you start. And the terminal angle, thinking about the word terminal or terminate, it's where you end things. So like if you're thinking about the movie Terminator, I don't know how many of you have seen that, but anyways, thinking about the movie Terminator, the terminator was sent to like end people in short. So the initial side, we're always going to be starting on the positive x-axis. So we're always going to be starting over here. And if we have a positive angle rotation, I'm going to sometimes say we're going to rotate up from that initial side. So like kind of moving in this direction. Oops, sorry, it's not, there we go. Moving up. But there's a better way we can describe that. The way we can describe that is counterclockwise. Oops. Stray mark there. Now, I know a lot of us, myself included, don't typically use like the old analog clocks, you know what I mean? Like you have a circle, you've got a circle, you've got times here, you've got 12, 6, 3, 9, and you've got other times here, and then like the hands of the clock rotate in this direction. So the hands of the clock rotate in that direction. That's why we call that direction clockwise. The opposite direction, we're calling it counterclockwise. So positive rotation starts on the positive x-axis, rotates in the counterclockwise direction. Now for negative rotation, similar in nature, those are going to be ones that are rotating in the clockwise direction. So they still start at the positive x-axis, but in this case they're kind of like rotating down. So this one, it's got an angle, the positive rotation has an angle of 135 degrees. Thinking about the rotation here, every quarter, like once we rotate all the way through the first quadrant, that's 90 degrees. It's another 90 degrees, so we're at 180. Another 90 degrees, we're at 270. Another 90 degrees, we're at 360. And then same thing works in the negative direction. So like if I were to rotate from here down to here, that'd be negative 90 degrees, negative 180, negative 270. I'm getting a little sloppy. Negative 360 there. So positive and negative angles of rotation. Let's draw 3 of these together, and then I'm going to have you pause the video and then do the other 3 on your own. So the first 3 angles, we're going to start off with 320 degrees. So again, kind of using those references that we just talked about with 90, 180, 270, 320. Sorry, 360. I'm reading 320. We're going to start off on the positive x-axis again. So I'm going to draw this in red so it's a little easier to see. So I'm going to draw my initial side over here on the positive x-axis. And I'm just going to slowly rotate around. So I'm going to start with a segment, or not a segment here, a curve that's starting off on the initial side, and we're going in the positive direction. That means we're going counterclockwise. So we're going 90 degrees. We got to keep going. 180 degrees. Got to keep going. 270 degrees. Got to keep going. Now, we don't need to go all the way to 360, so we're not going to complete the circle. We're going to 320. That's 50 more degrees. Now, think about what you know. If each of these quarter rotations is 90 degrees, half of one of those, so like if I were to go halfway here, that'd be 45 degrees. Going a little further than that, we're going to call that another 50 degrees there. Now, one thing I would like you to include on these is draw an arrow that indicates, it's kind of like pointing to that terminal side. Kind of gives us a good idea of which direction we're going. Now, in general, we should be starting off on the positive x-axis and going in a pretty obvious direction, but sometimes it's not super clear. So make sure you're drawing an arrow. Let me zoom in a little bit on my kind of messy arrow there. Make sure you're drawing an arrow pointing to the terminal side. That indicates that we started off on the positive x-axis here, rotated in this direction, and this is the direction we're heading. For negative 110 degrees, we're going to start on this positive x-axis again. So starting over here, drawing the arrows in my rays. We're going to go in the negative direction. Now, negative 110, we're going to go down, and that's negative 90. Negative 110 is not that, like if we're thinking again, if this is another 45 degrees, we only need to go 20 more degrees. So we're going to maybe go, whoop, that didn't work. Let's try that again. Maybe a little bit like that. Now, folks, I don't expect perfection. I just expect good effort. Now, one thing to make it perfect is label. So we started there. We started on the positive x-axis. We rotated down in the clockwise direction, rotated down to negative 110 degrees. And the best way to prove that it's negative 110 degrees is to label it. Man, my stylus is not picking up everything. So like the previous one, I probably should do a better job of labeling that as positive 320 degrees. Now, if somebody were to go and measure that, would that be exactly 320 degrees? No. But you know how I know it's 320 degrees? Because we labeled it like that. This is one of those times where you can say, well, it's correct because I said so. Now, you got to be within reason here. Like, if you were to say on the negative 110 degrees, if you were to put this and label that as negative 110 degrees, if I can label things correctly, I would say no. That's absurd. I'm not looking for perfection, but I'm looking for, like, reasonableness. So it's got to be at least in the right quadrant. I would also be a little skeptical if you put negative 110 over here. You got to use some frames of reference, but again, for these, it's not going to be perfect, and that's okay. Now, 990 degrees, again, just as with every other angle, we're starting off the positive x-axis. I'm going to finish off that ray there. And we're going to go 990 degrees. Well, that's over a full circle, so we're going to kind of start forming a spiral here. As we get further and further out, we're going to have to indicate that we're going more than 360 degrees. So we're going to have to kind of like expand the spiral. I'm actually going to redraw that just so it's a little tighter of a spiral. So we've gone 360 degrees. We have 630 degrees to go. Well, that means we have to go another 360. Think about what you know if any of you are like, well, basketball fans or snowboarding or skateboarding or whatever. You can do like tricks in the air where you're rotating 360s, 720s, and there's also 180s. There's also the infamous 1080. We got to keep going. We're going to keep going over and over and over in multiples of 360. Well, we've gone 720 degrees so far. That means we have 260 degrees left. Sorry, 270 degrees. I misspoke. We're not going to go another full circle. So we're going to kind of take this slowly. So right now we're at 720 degrees. We're going to keep going, add another 90 degrees. So now we're at 810. Add another 90 degrees. Now we're at 900 degrees. Add another 90 degrees. Oop, that was bad. Add another 90 degrees. Now we're at 990 degrees. And so our terminal side is actually going to be down here. And making sure that we're drawing the arrow indicating which direction we went. So there's 3 examples of the types of angles we can work with. On the example 2, I'd like you to take a moment, pause the video, try those 3 angles on your own. We got 45 degrees, we got negative 315 degrees, and we got 405 degrees. So pause the video, do those 3 angles, come back, and we'll pick it up there. Okay, you paused it, you've come back. Obviously, I totally trust you. I believe nobody just kept watching the video. Okay, 45 degrees. Draw that initial side. 45 degrees. We're going in the positive direction, so we're going in that direction. We're not going to go a full 90 degrees. We're just going to go halfway. So I'm just going to draw my end array right there already, my terminal side, and there we go, 45 degrees. Negative 315 degrees. Again, starting off on the positive x-axis here. Negative 315, we're going to go down in the clockwise direction. So there's negative 90, negative 180, negative 270, and we're going to have to go a little bit further. We're not going to go to negative 360. We're not going to complete a full circle. Negative 270, to go negative 315 degrees, we got to go 45 degrees more. So we're going to go about there. Let me draw that end terminal array there. And let's do a good job of labeling it. I'm not always the best at labeling it, but that's negative 315 degrees. 405 degrees, positive direction. We're going to start off, as always, on the positive x-axis. There's our initial side. Positive 405 degrees. That means we're going to complete a full circle. Full circle, remember, 360 degrees. So we're going to complete a full circle, kind of expanding our spiral. So we've gone 360 degrees. To get from 360 to 405 degrees, we got to go another 45 degrees. So it's going to be another like halfway to the next axis. And there's our angle, 405 degrees. I want you to pause, stare at these 3 images. I'm actually going to tweak the second one because I'm not, that was bad. I'm not super happy with how it ended up. I'm going to actually redraw it. I'm cheating a little bit. Looks something like that. Stare at these 3 images. Do you notice anything? What do you notice? What you might notice is on the next video. So tune into the next video, same bat time, same bat channel.